Let's do question 8-55 on page 8-33 in the Jeppesen Study Guide. And you want to have all the tools ready to get the job done. So that's your navigational plotter. You want to have your E6B flight computer. You want to have your very basic calculator. You want to have a pencil. I prefer a mechanical pencil, but a pencil, any pencil will work. And one more thing I like to use that they don't really mention in books is I like to use a magnifier because it's difficult to see all the little print writing on the charts when we go to them, and this really can help. And this is a cheap $2 or $3 item you can pick up anywhere, and it just folds into itself, and you can bring that into the test. Okay, here we go. Oh, there's one more thing you should have just to start. Get one of my flight time sheets and fill out the sheet as you go along. And that's what we're going to do. So we're going to do question 855. And we'll fill out our sheet as we do it. See if we can put both in the camera here. Okay. So it says, what is the estimated time en route from Sandpoint Airport? So let's write down here on our sheet, Sandpoint Airport, which is in Area 1, so I throw the 1 up here, to St. Marie, so St. Marie, and that's in Area 4, so I throw the 4 up here. Now you know the direction of flight, because you won't mess it up. They say that the wind is 215 at 25 knots. They always give you the wind and the direction and the speed. So we write that down here. Our wind is 215 degrees at 25 knots. And then it says the true airspeed is 125 knots. So you just write 125 knots. And in every question they give you the wind information, they give you the true airspeed. Sometimes they even add on time. But in this question, they're not asking you to add time in, so you don't have to worry about that. Okay, so this is the given information. We know that these two you have to find by looking at the chart on page 425. And remember, you got your paperclip in here, so you can come right back to the question. And if you're smart while you're studying, you may want to write the question number right at the top of your page, 855, so you don't lose your place. It's all about organization, my friends. So let's switch over to that chart. Let's look in Area 1 for Sandpoint. There's Sandpoint area, Sandpoint Airport in Area 1. That's Area 1. And look for St. Marie in Area 4. There's Area 4, and there's St. Marie, that little strip right there. So you got Sandpoint up here, St. Marie down here. Let's bring this down a bit. Okay. This should be a relatively easy one. First of all, you take your trusty plotter, you're going to use the straight edge, and you're just going to draw a line right between the center of the two airports. I already did it, I'm just going to go over my own line. But just like that. So you push down on your navigational plotter and just draw your line. And make sure to extend those lines past the airport. It'll make it much easier to find the lines later on. But right off the bat, do you notice something about the angle between the two airports? There's virtually no angle. It looks like they're exactly in the same line of longitude, the same exact line. But we'll see. Once you've drawn the line, the next thing you want to do is measure the distance between the two airports along the line. And you remember which side of the plotter to use, the less busy side, the sectional scale side. So let's do it. So I put on one end on the airport there, up at Sandpoint. I put the other one on St. Marie. And it looks like it's about 58 or 59 nautical miles. So the question is which one to use. Just make one up. Close is close enough, it may be good enough. I'm just going to say it's 58 nautical miles between the two airports. So I'm going to go over to my sheet here and I'm going to write in the distance part 58 nautical miles. So I found my distance. The only thing I have to now find is the true course between the two of them. And I want to know the true course from Sandpoint to St. Marie. So what I do is I look for a line of latitude. There's a line of latitude that crosses our line between the two airports. And then I draw a dot right where they intersect. Then I look for the hole, and I put the dot under the hole, and then I take the straight edge of the protractor or of the compass and make sure it's laying right along the line of latitude. Sometimes easier said than done. Even harder when you get a camera in the way. Okay, so we know, forget about what the numbers say here. If you know this is east, and you know this is west, and you know this is north, then this must be south. If this is south, what number must this line be? It's got to be 180 degrees. It's got to be. So our line for going from Sandpoint to St. Marie's looks like it's about 1 or 2 degrees off. I'd say 1 degree off. So 1 degree to the west of the 180. So I would say this is 181 degrees. And that's your true course. 181 degrees is your true course based on these measurements. And that looks about right, because that looks like to me 180 degrees. If you're going from this airport to this airport, you're traveling a 180 degree course. But what if you were going from this airport back to that airport? Then you'd be going exactly 180 degrees opposite. You'd be going about 0 degrees or almost totally due north. Start getting your bearings. Okay, we no longer need the chart anymore because we found our true course and we found our distance. We have the other information and now we just have to find ground speed. And what do we use to find our ground speed? First, let's go back to our question. We know our question was 855. There's 855. There's our paperclip. How do you find ground speed when you have all this information here? You know it. You use your trusty E6B calculator using only the wind side. So, before you start putting your numbers in, make sure that it's clear. Make sure there's no dots that you left on here, because then you'll make a mistake. It's clear, and then we set it to what I call 0, which is putting the 100 arc, this arc right here on the movable card, just under the center hole. I'll try and angle that for you. So just under the center hole. I'd say that's about right. Okay. Now, first thing we look for is our true course, which we know is 181 degrees. So we're going to plug our true course into the arrow where it says true index, just like we did in the E6B practice stuff in the other videos. So we're going to put it on 181, about there. So now we're on 181. This is still on my what I call my 0 point, which is the 100 arc. And then the next thing we do is look for the wind speed. Always the same method. First you put your true course under the true index, then you look for your wind speed. And your wind speed was given at 25 knots. We now know that every one of these dark arcs represents 10 knots from the center hole, from this base arc right here. So 10, 20, and then each one of the thinner arcs are 2 knots. So 22, 24, and then the little space between them is 25. So 2, 4, 5. So now we have our airspeed represented graphically. We have our true course represented graphically. We got 2 more bits of information to enter into the computer before we get our answer. The next thing we look for always is plug in the 215 degrees under the true index. We don't worry about the true course anymore. Just get the wind direction and stick it under the true index. Rotate this. So you rotate it to 215 degrees. So we go over to 215 degrees. Thusly, you'll notice that the dot moved. Okay, so now we have the 250, we have the wind speed plugged in, and the last bit of information we have is the true airspeed, which is 125 knots. You simply move the card, you slide the card so that the 125, the arc representing 125, is under the dot. So there's 120, look under the dot, see 120, 120, 120, I'll just get a your angle, 122, 124, and the little space between the 4 and the 6, that's 125. Now you have 125 knots true airspeed represented graphically. That means that the answer, the ground speed, is the arc, the number of the arc represented in the center here. So let's look in the center. Let's see, we know that that's 90, so this must be the 100 arc, and it looks like 102, 104, somewhere between 103 and 104. Can you see that? So it's a rough call, at least with my eyes. 2, 4. I'm going to call it 104. I can just see the line for the 104 arc. So I'm going to call this a ground speed of 104 knots. Okay, we don't need this anymore. We're done with that. Now it's all calculation, and very simple ones at that. There is no added time, that's why I X'd it out. You might say added time is 0. Same thing. Okay. Now, use the formula I put together and plug in the numbers. What is the distance? We measured the distance at 58 nautical miles. So just write 58 nautical miles. Divide that by the ground speed. Well, the ground speed is 104 knots. 104 knots. Then you multiply that by 60 minutes. And you say, how do I know to multiply by 60 minutes? Because you always multiply by 60 minutes. That is a constant in this formula, so that all your answers come out in minutes. The only things that vary in this formula are the distance and the ground speed. So let's do our math. You grab your $1 calculator, and let's plug in the numbers. It's 58 nautical miles divided by 104 knots, gives you a 0.55 fractional number, multiplied by 60 minutes. That gives you 33.46. So I rounded up to 33.5. 33.5 what? 33.5 minutes. The answer will always be in minutes. That's why I included this conversion factor here. It will always give you your answer in minutes when you use this formula. So 33.5 minutes. Let's see if there's any answers here that are close to or exactly are 33.5 minutes. So we're on question 855. That's 855. Let's see, 33.5 minutes. Not 38. 34 looks close. 33.5 minutes is pretty much rounds up to 34, so that could be an answer. 30 minutes is too low. So then I would agree that the answer is 34 minutes. And the answer should be B. So let's see. And the answer is indeed B. Okay, why wasn't it exactly 34 minutes? Because there were variations in the way I measured using the plotter, the way I measured using this device. There's always going to be a little room for distortion. But there's enough range in the answer set here for you to find the one that's the closest. Okay, I hope that helps. That's the end of this problem. And they're all answered just like this.